weather system, we could just use observation of the real world. We could also use theory to understand the underlying dynamics, or we could use the rotating tank as a bridge between the observation and the theory. The Weather in a Tank project was designed to teach students the essence of important weather and climate phenomena. The rotating tank apparatus is made of a rotating table who is rotating at variable speed according to the phenomena that we want to study. And the tank of water representing the fluid, like the atmospheric fluid rotating on the Earth. We have a view from a co-rotating camera, which is viewing the tank like us sitting on Earth viewing the weather phenomena. One might wonder how much rotation affects the behavior of, say, weather system or eddies in the ocean. To illustrate this, we are playing with two experiments, one tank of still water, non-rotating, and one tank of water who is rotating on our apparatus. Here we have a tank of still water. We are going to disturb it by using my hand. Imagine this is like a disturbance in the atmosphere or wind blowing over the ocean. Disturbing slightly by going in and out. And I'm introducing a few blobs of dye to see how the water is actually moving. So they can see the fluid spreading in all directions, both horizontally and vertically, and intermingled. Here we have a similar tank, but it's now rotating, and we have a view from the lab and a view from the co-rotating camera, which is appear on this TV monitor. Let's disturb this water again in the same manner as before, simulating like wind blowing over the ocean or a disturbance in the atmosphere. Look at the movement of the dye in this rotating system. You notice curtains of dye forming. It's not going in all directions. It's creating pattern in two dimensions. If you look at the view in the co-rotating camera, you have swirling motion with organized streaks of dye, red and green. This shows two-dimensional turbulence motion, which observed on all rotating systems. It's particularly evident on Jupiter, which is a fast-rotating planet. And the swirl here of red is very much a reminiscence of the red spot on Jupiter. In the real world, air movement are generated by temperature difference. Here we have another tank rotating, but with a can of ice in the middle. The ice in the middle represents the pole. The outside of the can is at room temperature and represents the equator. From our everyday experience, we could imagine that cold water sinks near the can of ice and warm water will rise on the outside. As before, we notice the dye falling in organized pattern like curtains, but on the surface we'll see movement. By doing this experiment on the rotating system, we are noticing a much more turbulent motion with warm water going towards the can and cold water coming out in an organized pattern very similar to weather system. The rotating tank has been proved very successful in the teaching of weather and climate here at MIT and at other universities, and students love playing with the water and gets their hand wet.